Recording
right?
is
So,
on.
so you can see we first of all started with Luis talked about the computers storing information, right? Hello, good morning, welcome. Have a seat. Software engineering or data? Data. All right. Your name, please. Mhm. Okay. All right. Welcome. Yeah. So yeah, we started already. You just continue with us. Okay. So we're talking about introduction to computer science. Yeah. So these are the different definitions which I've received from your friends right now. Okay. We started with a computer storing information. Are we there? Then we went down to seeing data. We went down to garbage in, garbage out. And then now we're actually talking about what input. And we're seeing that what data is actually an input. Are we there? Hmm? So you give the computer or you feed the computer with data as an input. And what does it do with it? It processes it. So see that what? We have one step. Let's see. Let me start here. So we have one step. So let's see. We have the inputs. After inputs, um we have processing. So you feed it the data, that's the input stage, right? Then now it has to process that data. Are we there? Then you are expecting an output. Hmm? So you can either display that output to you or store it for future use. Are we there? That's clear, right? So if I see that your definitions are top notch, like well, actually used it to like I'll outline the different processes or different stages you can get with a computer. Okay, let me go to the lecture notes. Okay, so introduction to computers. What's a computer? So I mean, you guys, you all said the computer is an electronic device or electronic machine, whatever. Okay, that does what? It takes input as data or instructions. It processes it. In bracket, we have what? Things using programs. Because on by processing, we mean there should be some sort of instructions directing the computer on what to do with that data. Are we there? And those instructions are what we call programs. Exactly. Hmm? Or a software. A software is just a series of instructions telling the computer what to do with what it has. That's clear. Okay. Oh, then it gives output based on what? The input and the processing it has done as results. So that's where the garbage in, garbage out comes, right? Yeah, based on the input, knows what to give out. And based on the input and the processing. Because let's say for example, if I give mm, well, this is not necessarily computer related, but let's say if you give um okay, when you go to the grinding mill, I don't know, you know where you grind corn and all of these things, right? If you give, let's say, corn chaff, right? You have sometimes they scratch the corn. I don't know, sometimes they peel the corn, right? So there's a machine that if you give with the corn, it's just going to peel it, right? So its own the let's say the it has been programmed to just peel. And then there's another machine, let's say if you want to prepare corn fufu, right? The same corn, so it's same data, right? Besides different processes, right? Because the one for corn fufu is going to crush the corn. Are we there? So it's that the data is the same, or the inputs are the same, but the processes or the program is different. As such, you have different outputs or different results. Exactly. Hmm? So that's like a computer, right? Yeah, basically the data you give it and the program, it knows what to give you as the output. Okay. Uh okay, so a typical example of how this happens is as follows. So you ask a question using the calculator app on your computer, like 2 plus 2, that's the input, right? Yeah. And then your computer processes or computes it. That's like that's okay. It's using the inputs you gave it. So that's like the processing part. Are we there? Then it shows the answer on the screen. That's your output. That's clear, right? Okay. So why do we use computers? Why do computers? I mean, that's a question. So let me just go up. Let's answer together. This time around, I'll start with uh, Luis. Why are you smiling? Okay, let's hear Hassan's voice. Okay. So for computation, for designing, you summarize it with just a work easier. All right, that's good. That's good. Yeah, leave it. Say something. Mm-hmm. That's very true. Yeah. So to watch movies, browse on the internet. Yeah, those are day-to-day tasks which we use a computer for, right? Yeah, that's very true. Um, Tina, can I say something? Yeah, I've added play games. Yeah. You can use that phone to play games, right? And your phone is a computer. And I mentioned calculator is still a computer. Okay. Um, Louis chipping something. Yeah, very true. Yeah, research. Like, yeah, that's right. Okay, let's look at what's here. So, why do we use computers? So they help us to carry out many tasks like write documents, like yeah, typing, which you had mentioned of, browse the internet, maybe for research or whatever, watch videos and listen to music. Yeah, most of the times once people um let's say once you get your phone, you're like, okay, can I go online? Can I watch a movie with this phone? I mean, you're thinking those basic stuff, right? That's should I say you need or you want? You want, right? It's not really a need, but yeah. Um, send emails and messages. store information, very important, right? Very important. That's very true. Play games, do calculations quickly and accurately. Because yeah, it's not all about doing the calculations, right? But accurate. Yeah. Because it's just like you go and get a calculator and you put two plus two, it give you 20. It's not really doing what you want, guys. No, that's not the desired output. Yeah. Okay. Types of computers. Okay, let's discuss again. Types of computers. So computers. Um, so what are examples of computers that you know? Or rather, let me look at the types and then from there maybe we can okay. So the categories of computers, right? We have two, general purpose and special purpose. Are we there? Okay. So um I'm going to put that and then we're going to see okay types of computers and then we'll link them under those two subtopics or two categories. Are we there? Okay. So we have general purpose or where the blackboard, the whiteboard. So the whiteboard is here. Okay. So we have general purpose computers. Let me see. Okay, so we have general purpose computers and special purpose computers, right? Let me put the word here. Whiteboard. Yeah. Let me see. Okay, not bad. So I have general purpose and special purpose. But first of all, we have to see the different types of computers so that we can classify them under general purpose or special purpose. Okay, so types of computers we have, well, there are many types, but we commonly know the ones which we commonly know or use, or let's say know, right? One desktop. I mean, we've all heard of a desktop before, or even seen one, right? There's one there. That's a desktop. Hmm, yeah. Oh, so it sits on the desk, like you can see there. We have laptops. So laptops, what you have to carry. So laptops. They're everywhere now. Uh, tablets slash smartphones. So we know this, right? Yeah. Then we have smartphones. I think everyone has a smartphone, right? Mm, okay. Uh, servers. We have servers as well. So servers are powerful computers used mostly by companies. Are we there? Mm-hmm. A quick question is main measure of tablets slash smartphones. How about your Churonko? We know of Churonko, right? They're computers too. Mm. Are we all? That's fine, right? Okay, me should have put maybe slash Churonko there. Should have made it. Yeah. Okay. All right. Let's continue. So, desktops are they general purpose or special purpose? General purpose. Why? Okay. Okay, first of all, let me get
Desktop, we know the normal everyday desktop, we use it just for normal basic tasks to do what normal laptops do, documents, So when we talk about specific maybe computers now, they are designed for maybe specific activities.
Mm-hmm.
The desktop we know is just for normal everyday task computations, and so I think that's why desktops are
General
general.
purpose. You can watch movies, you can browse, and this and that. Okay, I get you. All right. You said it depends.
I'm saying that it depends because, for example, when you go to the hospital,
Yeah.
we have desktops that are used just maybe for monitoring or not, maybe just for I don't know this example well. Maybe at labs we have desktops that have been stationed there and configured just to do a certain kind of computation, maybe urine analysis or whatever. That's what I'm saying
Mm-hmm.
that it depends
Okay,
on.
I get you. All right. Okay. We'll eventually see that will go down. So laptops, general purpose or purpose, same thing. Okay. Tablets and smartphones. Okay, let's talk about the ones which we use.
Once we use in general,
General,
probably
right? Yeah, yeah, general purpose.
if you, yeah, if you go like to some people, they have tablets that are used just to
Yeah, for
sell tickets.
yes, that's true. Yeah, yeah. Then servers.
Servers, I think servers are special.
Okay. All right. Okay. Let's cut the chase. Let's go down. Let's see what general purpose computers are and what special purpose computers are. Okay. So general purpose computers. So these are machines or computers capable of performing a wide range of tasks. So they are versatile, right? Yeah. They are highly flexible and user programmable for diverse needs like entertainment. You can say, okay, think like graphic designers, like designers, right? What, yeah, video editors and so on and so forth. So you see, like all of those fall under the entertainment domain. Then word processing can also be for word processing, like um maybe installing your software, going to it and typing a document, typing your reports, PowerPoint and whatever. Software development, if you're a programmer, maybe you have your text editor, your IDEs that you go in, you program a computer to do whatsoever. So yeah, software engineering guys are going to see that together. Data analytics as well. Data analysis. So you have a computer that can do all of that. Can also do your data analysis and word processing as well. Word processing again, no problem. So you see that a general purpose computer can do so many things. Are we there? Yeah, a variety of things, a wide range of tasks. So, okay, I want to watch movies. It's there for you to watch your movies. I want to play games. It's there for you to play your games. I want to write my report. It's there for you to write your report. I want to maybe go online, browse the internet. It's there for you to browse the internet. I want to maybe create a software. It's there for you to create a software. So it does a lot, right? Yeah. It's just like a jack of all trades. Yeah. Examples include laptops, desktops, tablets, and smartphones. And like you said, it depends. I like that. That's cool. Okay. So special purpose or specialized computers. So these are computers optimized to perform a single task, mm, or a limited set of tasks efficiently. So unlike general purpose computers, they are not as flexible. Mm. They have they have fixed functionality and are often embedded within other devices. Yeah, that's true. So they are faster and more efficient for their own specific jobs, right? They are built for that. You get it? Yeah. But not adaptable as in be. where they're built for a specific thing every day. So it's not feasible as the general purpose computers. That's clear, right? Okay. So examples include, so we have examples here, right? So ATMs, of ATMs, right? In front of banks down there. Yeah, automated machines. So they handle cash withdrawals and banking transactions. So I mean you cannot go there and say you have to play games, right? Or you cannot go there and be like, I want to watch a movie. I mean, it's it to handle those withdrawals and okay, I go slot in my card, do whatever I want to do there, and then receive like okay. Then traffic lights. And that's the point I like, is that a computer? Is it? It is, right?
Controllers. Not the
Mm?
lights.
Yeah, yeah.
It's like the back end.
Controllers.
Exactly. Yeah. So traffic lights for controlling traffic flow, right? So um I'll talk about controllers. So yeah, yes, lights obviously. Lights cannot be computer, right? Yeah, but within that that panel, that stuff that you see here, something to control that effect that you're seeing. I will, for you to know, okay, right now I should turn green, right now I should be red, right now I should be orange or whatever. There has to be something giving it the instruction what to do. Based on what? Some data or some input. Are we there? Okay. Medical devices like MRI scanners, patient monitors, and blood pressure measuring machines, and so on and so forth. Like made mention of going into labs and the specific computers which have been programmed to do specific tasks, right? Hmm? Is that clear for everyone? When you are good, right? Are you tired? Oh, yeah, sure. Yeah. All right. Well, home appliances like controllers in washing machines, microwaves, fridges. I think there's um machines that in our homes. Like I say, there's some fridges that you actually see screens,
Yeah.
right? Microwaves and washing machines, right? Like I don't know. I see a screen. I've never really I see the movies actually. Yeah, you can actually see the screens like tell you that maybe this thing is at the top layer and stuff like I don't know. Maybe you can use it to relate the temperatures and stuff. I mean, right? So that's a computer. So, well, why we are going to be moving forward? You see that a computer does not necessarily need to have a screen because I know, well, as we're speaking, you guys are like, okay, I can picture a screen actually. Exactly, I trying to picture of those a mouse and all of those things. I'm like, nah, that cannot be a computer now because it's not a screen, it's not a keyboard. But while we move forward, you see that these ones are just getting younger. Are just for the user, yeah, for the user to have that ease of using it. Yeah. Mm-hmm.
That's a question.
Go ahead.
So does that mean that the fridges that we have now, the ones without the screen or the ones you can program remotely, I can maybe tells you where the different food components are or tell you how to read the fridge. I mean, the normal ones that we have that we buy. So most of do you consider that as a computer? So
Well, it's not the switch that the computer, right? It's a switch.
yes,
Yeah, right. But it has let's say most of them have um come again.
The programmable circuit.
Yeah, you can put it like that. Yeah. The programmable circuit, right, which has these components that we're going to see under here, which help it to maybe get input, process it, and maybe store it or output it. So output must not be necessarily on a screen, right? Could just be helps.
do you consider that as a
I think should be considered a computer.
Yeah.
Mhm.
Like
Like
whatever is
a
inside,
manual, a
not
manual
necessarily.
fridge.
Okay, manual fridge. You're talking about a
You know,
manual
like
fridge.
fridge,
The normal
the
fridge,
normal fridge that we have in
yes,
our
yeah, I
house.
think because
It's not.
there are
Mm.
moments where it regulates the temperature. Like that's already storing of data now. So you understand that
You manually set the temperature to a normal fridge.
already.
Yes.
Okay.
How cold you want it to be. There's a thermostat in it. You manually
You
do that.
manually do that.
Yes. So if it's now a computer, you can now press this button that I want at 6 degree cold or 10 degrees cold. I think that's what I think. But if it's something that you're doing it manually, it's not. But if you now put like the press this button that I want 60 temperature at 6,
Yeah.
after a while you're actually getting that coldness from it. I feel like that's the outcome and that's the result. If you manually do it yourself,
Okay.
Yeah. Go
Yeah, I think just the fact that you manually do it means that stored it in accepted data. Right? Because you input, that's another form of telling the computer what to do.
Mm-hmm.
You inputted before from the start that you said you manually do that. So if inputted it, he understands that okay, I want 90 degrees, for
Yeah.
example, just say you want 90 degrees. That 90 degrees has to stay constant. If it's no computer, then it will not understand that it has to put that data or that information all through. So that's the aspect of storing the data, then giving you the output now is the temperature that it's
It the output.
it
Yeah. Yeah.
outputs with the
Output. Yeah.
pressure. It might be considered a computer,
Okay.
not just a base level computer.
All right. Thank you. Because we're going to. I don't know if it's part of this notes, but there are generations of computers, right? There are generations of computers, and when you even go far back, they talk about the abacus. Have you guys ever seen the abacus and stuff? But it's just for calculations, right? And it's actually exactly, and there you don't even see. I don't think there's even any
The typewriters, it's like an abacus.
No, like how do I explain it to you? Have you um,
abacus.
have you
You can even just research it there.
this this football like where you can
Uh,
like it has this thing that you
the
can
baby food or
maybe
It's
whatever.
food.
difficult.
Yeah,
It's just like a different how like it's like peers.
yeah, tablets or whatever.
No, not really peers, like different how do they call it in English?
Very cheap.
Chips, yeah, different chips like that, like different colors now, and then you just move them like just to calculate it, add, subtract.
Exactly. Just play. So my focus there is that there's nothing electronic about that even.
Okay, alright.
Are we there? Yeah.
So you're saying that a computer is anything that can that takes information, processes the information, and gives you an output.
Yeah.
That's what you're
But yeah. But now coming.
even if it's not electronic.
Yeah, even if it's not electronic, right? But the issue now is the fact that with this our modern age, we're looking more at the electronic aspects of it.
Because looking at this abacus, it doesn't even look like it's an electronic device.
Exactly.
Yeah, seen here, it just looks like one.
Right. That's why we have the computer generation now. And right now, generation is more electronics. Okay. In such a way, I mean,
So we might have a
that
different definition of the computer right now.
exactly. Are we there? That's why I made mention of the calculator and
Yeah, that's what we say.
but I'm seeing something online. They're saying
yeah.
that an abac is not a computer, that it's rather a modern calculating an ancestor of a modern calculating device.
That's why I say based on the computer generation, right?
Like
Right now, you not actually see it as that, right? Mhm. You get it? But I think we're in the foot of
Why in the
it like that, right? You see, right now, and the fifth generation has its own classification of what a computer is. Start talking about integrated circuits and all of those kind of things, and we're even moving up to AI, quantum computing, all of those things. So let's say people in next five, let me say five, 10 years, 20 years. I don't know. I don't even know what to
I
say.
see this as not computer.
Yes,
Yeah.
are we there? Mm. Like maybe they don't even need keyboards to type. Maybe they just need to think and it goes. So now we see all keyboards will be like, what are these guys using? That's clear, guys. Okay, let's continue. Okay, so main parts of computers. Oof. All right, so I think we have main parts.
Just a
Main
question,
parts.
please.
Yeah, go ahead.
It means that for general purpose computers, it means specific purpose computers are a subset of general purpose computers.
Yeah, you can put it that way because even in part of the well, it was made mention of the fact that the let me see. Okay, that are often embedded within other devices. Yeah, like even let's say you have a computer which doesn't maybe do calculation and you want something which actually does a calculation or computation, right? You can insert it into your computer to do the calculating for you. A particular thing which you have programmed outside, right, before inserting it into your computer. You can say that one is special computer, right? Yeah. Or you have a different device and you want it to do something.
Okay, just like the Malays in PS, they can connect and
Okay.
use to play
Yeah,
games.
yeah. Let's not go there. Okay. So main parts of computers. We have all computers have two main parts. So software and hardware, right? Hope I'm getting. So we have software and hardware, and they are further subdivided as follows. So first of all, we have software and hardware. So well, the number one is hardware. So is that what? Hardware are the physical parts of the computer which you can touch. So I mean, we all have laptops, guys. So which are the parts which you can touch? The laptop example, and
Keyboard.
the keyboard. That's very true. Yeah,
My screen.
your screen. Okay, the monitor. All right. Mouse. Yeah, that's true.
Of the ports.
Yeah, you can touch the ports, right? Can you touch them? Yeah,
Mm,
yeah, touch the ports. Ports. The thing is, this is just the outer, right? This is not actually the ports. Yeah, the ports itself. It's just something to help you communicate with the ports, right? Yeah,
Or maybe to call an external device.
device. Yeah,
the mouse.
yes, the mouse. Yeah, Tina made mention that. Any other thing?
On our computers.
Not necessarily go on a computer, right?
My laptop charger.
Okay. Yeah. I mean, okay. What else?
Laptop charger for real.
Ah, it's part. Well, let's
The
say
courts.
right now, right? Yeah, you can see the codes. Hmm? Yeah, like okay, if I let me remove this mouse, or this we will call this a touch pad, right?
Mm-hmm.
Mm. But right now, where it's connected to it, it's part of my computer. So you can see my mouse, right? What else? What else? So we have printers. I mean, we use printers on the computer too, right? Um, most printers come with scanners and everything nowadays. So
Then this part, how do you call it? The
which part?
box.
That
Always call
one.
it the PC.
System unit,
Okay, the CPU.
CPU. Yeah. So that it has many names, right? Yeah. But
But not the PC.
no, not the PC.
The
The
PC
PC.
do everything.
Yes. Yeah. Personal computer, right? Yeah. Okay. Input devices. So okay, if hardware is divided into input devices, right? Input devices, we have processing unit, we have output devices. I think that should be all. Well, let's start with input devices. Okay, excuse me. Let me check the online. Uh, okay, I had some noise here. Online session. Okay, so let's come back. Where were we? Okay, hardware. So we said number one, the first type of input devices we used to give instructions or data to the computer. So we have A, the keyboard. So we know what the keyboard is used for, right? Yeah, so type letters, numbers, and other characters. Oh, we have a mouse. So mouse helps to at point, click, and select. The touch screen. Okay, I mean, phone, right? Yeah. Um, tap or control with your fingers. Yeah. Whatever process you have under there, it's not something, right? Yeah. Microphone, you give voice input, so it takes voice and converts it to whatever. Scanner, so copy images, transform hard copy documents, soft form, right? So those are all input devices. So it's like it takes something and sends it to the computer. Mm. Remember, I said the computer needs to be fed with something right, for it to do its processes. Yeah. Then number two, have processing unit. So the CPU unit is the brain of the computer. So brain as in all the thinking, processing, and everything is done in there or by that part of the computer. Mm. Okay, so there's some clarification there. So the CPU is not equal to the system unit. Mm. So the CPU is the brain, a single chip that executes instruction. Are we there? Yeah. Then why the system unit is the entire key.
Okay, so that is a system unit.
System units. Within it, we have the CPU.
Okay.
Should
Okay, that.
I bring it?
Yeah, maybe you should.
Ah, eh. Okay. Okay. So I'm sure you guys noticed me removing a cord from there, right? I needed the cord to be connected to the monitor itself. Are we there? So this is a system unit. So like I said, it's the entire case, a or box, right? Containing the CPU, which means within it is CPU. Are we there? Let me open it. Let's see. I'm not gonna play boy.
It's not gonna be understand. You must not open it now.
Okay. Mm, okay. This one looks clean. Yep. So that's the inside. So inside is a system unit, the packages, all that stuff, right? Yeah. So uh where can I
So
see
where's the CPU itself?
exactly? Let's see.
I think it's just a cheap ride.
Yeah, it's actually just a chip. I think it should be under here because mostly where the heat sink is, right? Yeah, because obviously it's doing all of that computation and stuff. So heat, are we there? Yeah, so I think it should be under here like that. Are we good? Yeah. So this is a system unit, and inside it now has the CPU. Obviously, it has other things, guys. Yeah, go ahead.
The CPU, is it all of that board
No,
or
no,
just
no,
a particular
no,
chip?
just a
Okay,
particular chip.
particular chip.
Yeah, just a particular. If you even browse online, like CPU, so it's just a square something. Yeah, yeah.
Just everything. Everything.
Every computer has a brain,
Yeah.
so it has a CPU, right? That is central processing unit where all the computations, calculations are being done. That's clear. Are we there?
This one is just external for your laptop is embedded on that.
Laptops almost.
This
Yeah,
one is for your monitor.
yeah. But the same small stuff here. Yeah, yeah. All right. I think that's fine. Okay. What else? So, okay, contain the CPU motherboard. So, we have the motherboard, right? This, come again. Yeah, yeah. The green stuff, which has all of those other ICs and stuff there. Uh, the RAM. So, where can we find the RAM?
There's
Suspecting that is the RAM.
ones that are standing up.
Where is it?
They be beside the fan.
Oh,
The
what?
one they sink.
This one.
Yeah. Those two guys beside.
Oh, yeah, yeah, yeah. Yeah. These are the, yeah. These two. Can we see? It's clear, right? Let me see. Hey, let me move it. She'll be there. The storage is our storage, right? Like the hard drive and the rest. I think this should be it, guys. This should be it. Maybe there's an SSD there, I don't know. Maybe there's an SSD. So hard drives, so hard disk drive or solid state drive for storage, right? Or maybe you guys open one day and see them. But I've actually opened it so many times there. So the power supplies were right, yeah, and then and other core hardware that make of the computer's function. Yeah, yeah, yeah. Very true. Okay, let me lose it. Hopefully, still in a right state. Mm, this way. Okay. So it's a good thing we had this stuff around. Let's help to show us some of these computer parts. So, okay.
So this one is like not related to the course.
Yeah.
So what kind of listen to?
Let's see. Well, with different night time. Yeah.
What was the normal closing time?
I mean, from the time to is 8 to 6, right? But we're going to close early today. Yeah. Oh. Eh, are we suggesting? We see as it goes. It depends on the content we have and how fast we deliver it to, right? Okay, so let's continue. So output devices. So we're done with input devices, right? I've done with some processing units, yeah, which I've seen many of it. Now output devices. So they show results. Hmm? Hello, yeah, can you hear me? Okay. Um, can you get me now?
Yes, I can get you now, Yannick.
Okay. All right. All right. Thank you. Let me share. Okay. All right. So, uh, we've talked about the processing units, output devices, we mention of monitors, screens, printers, and speakers or headphones. So, monitor, well, or the screen of your laptop, right? That's where you go to, right? In case you're expecting to see something on your laptop or your machine or your computer or your desktop. Printers. So printers transform soft copy documents to hard copy documents. They will have the speakers which or headphones which produce sound. Then storage devices, we have hard disk drive. We have hard disks which can either be hard disk drive or solid state drive, and these sit within the computer. And we also have external options. For example, we have the USB. Right. Well, I've seen a USB before. Let me see what I have one here. Yeah. So USB, right? Yeah. So universal serial bus. So we usually call it flash drive.
Yeah, that's what I wanted to ask if there's a difference between
I
USB and the flash drive.
don't really know where this difference actually. Is there a difference? Does anyone have any
I
idea?
don't know. They usually call it interchange. Like, but
Yeah. Some will be like flash. Some will be like USB. Yeah. Okay. So it's good to just know, right? They can also call it USB. Either USB or flash drive. So it's portable, right? Obviously, you can put it in your pocket, go store your documents, go somewhere, share with someone, right? Memory cards, mostly in the phone. Mm, yeah. They also have cloud storage, right? Google Drive, Microsoft OneDrive, um, Dropbox. There are many for cloud storage. Are we there? Are we there? All right. So how do computers understand storage? Like you get if you are going to buy a flash drive, you be like I need a 2 gig, right? 2 gig flash, 16 gig, 4 gig, all of this kind of stuff. Mm. Yeah, so that's what we're talking about. So some common storage units they include we have the bit. So abbreviation is just small b, right? So that's the smallest unit of data, which is can either be a single zero or one. So I'm sure we saw binaries, right, during the foundation level, right? Either zero or one. That's clear, right? Yeah. So a bit is either a zero or a one. That's clear, right? Okay. Then byte, byte. So that's the abbreviation, capital B. So a byte consists of 8 bits. Exactly. So it represents one character, like a letter or a number. So we talk about a character, we're talking about a particular key on the keyboard, right? Like ish. So wait, let's say if I press ish, the data that is sent to or the data that represents age is a byte, like 8 different bits, like ones and zeros, like 8 times. Hmm? So the computer sees it and like, oh, that's letter H. So why we're just saying our one stuff, the computer needs those 8 different bits to recognize H, or to recognize A, B, and all of those. Are we there? Even to recognize one, two, three, right? Mm? Yeah. Okay. Because we're the one seeing it like one, or the one seeing like zero. Computer just know that's a bit. However, that's what a bit is. All right. Then kilobytes, so KB. So that's 1024 bytes. That's 8 bits, 8 bits, 8 bits, 8 bits, 1024 times to make a kilobyte. So a small text document or spreadsheet is about a few kilobytes of data. Yeah. Let's see, most of the times when you come to stuff, oh no, let me see. If I go to documents or whatever, can only see how can we KB, KB data, that's kilobytes, right? This one is just 1 kilobyte. It means exactly 1024 bytes, right? Yeah. So yeah, that's it. Let me go back. Um, we have okay. So megabytes. We also have megabytes, abbreviated MB. I'm sure I've seen this right as well. Mostly actually see MB or GB. So MB, well, 1024 kilobytes or 1 million bytes makes 1 MB. I'm sure everyone we're talking about maybe subscribing to a data bundle. We're thinking like 100 megabytes of data, right? Yeah, exactly. So this is like the interpretation of it. Yeah. So a song, but right now we're talking about storage, not necessarily our data bundle that we use. Yeah. So a song or maybe a short video uses can be stored in the form of megabytes, right? Yeah. Like I don't know our songs here. Let me see. Uh Music. Maybe I have music here. Yeah. This is a video. Let's see. Detailed. I have it here in kilobytes. Maybe I have to transform it to megabytes to actually see what it does. Nah, let's not start transformations now. So a full length, okay, now it's gigabytes. So that's all about megabytes. Then gigabytes now abbreviated GB. So obviously 1024 megabytes will give you 1 gigabyte. Yeah. Most of them we mostly just say 1000 megabytes give us that, but 24 is there. Yeah. Okay. So a full length movie, especially with many seasons or a large software applications, can be in terms of GB, right? Yeah. They will have terabyte as well. So not only talking about movies and the rest, but also your flash drive, right? When you want a flash drive, which um, when you go to buy a flash drive, you are thinking in terms of capacity. How much data can that flash drive store? Are we there? So if you know, okay, I want to store, if the data which I want to store is just in terms of megabytes, I mean, I can even just go and buy 1 gigabyte of flash. I don't know whether it's out there, but you get something which is small, right? Yeah, but if you know you want to store much data, you be like, okay, 16 gig flash, 32 gig, right? If 128 gig, I think yeah, there's 128 gig right there. Yeah. And if it's too much now, you can start thinking of maybe hard drives, right? Yeah, 500 gigs. And after 500 gigs, we have things like what? 1 terabyte. So now that's it. 1 terabyte TB. So 1 terabyte is equivalent to what? 1024 gigabytes. Is that clear? Yeah.
Okay, so yeah, large photo collections, backups, your computer storage. Yeah, your computer storage, right? I mean, in terms of terabytes. Are we there? Then after terabytes, we still have another one, we have petabytes. Obviously, our petabytes will have more and more. But we're going to end petabytes. So petabytes is 1024 terabytes. Yeah, that's a lot. Maybe you start seeing those ones in servers like that. Yeah. Okay. Any questions so far? Let's not just be flying and some people are not. You can be taking down jotters, eh? Should not just be going.
Are you going to provide this to us?
Yes. These notes are going to be on ISLN. Yeah. Okay. So we have software which can also be considered as programs. Hmm? Okay. So a software is the set of instructions that tells a computer what to do. Are we there? So software is a set of instructions that tells the computer what to do. WhatsApp is a software. Then now when you get that WhatsApp is just instructions. It's like what are you saying? Oh, maybe that game that I used to play. It's just instructions. But yeah, that was it, guys. That's just it. Yeah. Okay. So softwares, we have system software. A system software basically runs the computer. Are we there? So, well, let's continue. It manages the hardware and runs applications. So if we say it runs the computer, now the computer is made up of what? Hardware and software, right? So if it runs the computer, then it means it should be able to manage the hardware and software as well, right? Okay. So they can be categorized into one, operating systems, which we commonly call OS. Mm. So operating systems like Windows. We've all heard of Windows before, right? Mm. Yeah. I mean, when you go to buy a laptop, even if you don't you don't know the laptop brands like Dell, Lenovo, and the rest, you be thinking of is it Windows laptop, right? Yeah. Okay. Well, Mac OS, you know of Mac OS, right? Yeah. Linux, people don't know of Linux. It's not that popular, but I mean, there's Linux out there. It might even be the highest that is out there. Linux for core functions. Okay, but that's for let's say laptops, desktops, right? Talk of are more as smartphones. Exactly. Android, iOS for iPhones, right? Yeah. I think it's a Windows for phones too.
Yeah.
I've once heard of it. I don't
It's
know.
Windows.
For
Windows.
phones.
I think there is this Sony Xperia.
Yes.
Sony brand normally uses Windows.
Yeah,
This
I've once heard of it.
Xperia, the Xperia brand and the Sony brand
Wow.
usually they are more simple than Windows.
I see. Wow.
It's very difficult. It just displays the thing.
Yeah, but yeah, it is.
Wow.
I'll finish using Windows on my laptop, so I get Windows again. Okay, yeah. So see, operating systems are everywhere, right? But I'm using them without even knowing. Obvious
I
that.
think
Yeah.
BlackBerry used to be Windows. Yes, BlackBerry.
Wow,
Yes, BlackBerry used to be Windows.
that's a good one. Okay, that's it. So we use operating systems in our computers. Maybe you don't actually know that, okay, that's an operating system, but know that for your computer to run, it needs an operating system, right? Okay, now an operating system allows you to start the computer, obviously, manage hardware and software, as well as allow you to interact with the computer. So without it, you basically not even do anything. Without it, this computer is just a box, right? Yeah, because you need it for the computer to know that, oh, the key of press on the keyboard is um the A key, the S key is the caps lock, is the shift, right? You need it to interpret maybe the mouse movements. Are we there? Yeah, all of these things you need the operating system for that. You need it to, okay, maybe when I double click on this icon, knows that, okay, that's a WhatsApp icon. He has to run the WhatsApp software. Are we there? Yeah. You even need it to go and look for where WhatsApp is found in your phone. Hmm? Because you can install WhatsApp, right? Which means it's stored somewhere. When you tap it, what happens? Right? So the operating system is the one managing all of those different processes. Mm.
Okay. Right. So it means the OS works directly in line with the CPU because the CPU is the brain.
Yeah.
Now, the OS is the one you're saying the OS does the direction, does the
Managing.
interpretation. That's more like another
Exactly.
brain. So I mean, does it that is it that they work hand in glove or
Let's see. Yeah, you can see, yeah, like you say, what's hand in glove, right? In fact, let me just continue with this stuff that, yeah, I'm saying we'll get it by the end of this. Are we there? Yeah. So um what's the name again?
Nine.
Lanye. Okay. So we're talking about the um system software. Are we there? So system software, the first thing is to say that the system software basically runs the computer. Are we there? So doing a recap, right? In case anyone not get it. It basically runs the computer. So it manages what? Your hardware and the other applications in your computer. Are we there? Okay. So it can be categorized into what? Operating systems, which are, for example, the Windows operating system, hmm, Mac OS for these Apple laptops, Linux. Have you heard of Linux before? Yeah. Mhm. So Linux has several distributions. Yeah. Then also, what does how does the OS help, or why do we need it in a computer system? So an OS allows you to start the computer, manage hardware and software, as well as allow you to interact with the computer. Are we there? Okay, let's continue. An OS has two main parts: the shell and the kernel. The kernel is the core of an operating system. It manages hardware like the CPU and RAM, as well as system resources. Are we there? It is loaded first and always runs in the background. Okay. The shell is the user facing interface and outer layer, providing a way for users to interact with the computer. This interface can come as what? CLI, which is command line interface, or GUI, graphical user interface. Note, the shell is how you ask for things, and the kernel is what does the work by interacting with the hardware. Okay. We have other operating systems like what? Android, iOS, which we made mention of, right, for mobile devices, smartphones. Okay, so let's just discuss that, right? So I've seen that um the operating system comes with a kernel and a shell. And a shell can be in the form of what? CLI, command line interface, or GUI. GUI is made up of what? Graphics, icons. If you can see a WhatsApp icon, then you know that's the GUI you're interacting with. Or that's the shell you are interacting with, but in the form of what? A GUI. Are we there? Is that clear? Mm. So that also tells that what this interface that we see is provided to us by what? The operating system. You get it? So if you go to, just like if you look at iPhone, you, even if you don't even, even if you don't see the cameras and the physical parts are outside, you look at the screen, you know, oh, that's iPhone. Are we there? To show that the iOS operating system comes, that's its own GUI, right? So it's identical. You see like see it, you know, oh, that's iPhone. You see that for Android now, that's Android. Just like Windows and Linux and Mac OS and the rest, right? Yeah, that's it. Just like you see some people like using Windows, but they want to make the interface to be like that for Apple. Yeah, for Mac, right?
I had a friend who had a Samsung, so he customized it to look like an iPhone. Even when it rings, you think it's an iPhone.
Exactly. You see, right? Yeah. But that just tells you that each of these individual operating systems come with their own features which are unique to them. Are we there? Hmm? Okay, so that's the shell, right? And that's the GUI. Now the CLI, command line interface. So like it says command line, which means you're just passing commands and it does it. Are we there? Yeah. Yeah, command prompt. Yeah. Windows has it, right? Yeah. That of Windows is a dark screen, you're just passing commands and it does it. So whatever I can do with the GUI, I can actually do it there in the command line, command prompt. Is that clear? So yeah, those of us who are going to be using the Linux operating system are going to see a lot of it. The Linux operating system, we call it terminal.
Yeah, on that. So, what makes you choose a particular operating system to use? Why would somebody use a Linux and another person using Windows?
Uh, Basically they do, I mean, based on this overview, right, you see how they do the same things,
What is
right? They
complicated?
just manage the hardware and the other apps. Like if you're just looking at that, then you should choose anyone to do your job, right? Yeah, because just like, how can I put it, the guy using iPhone still make calls like the guy using Samsung and the rest, right? Mm. But except if maybe there's some features which are peculiar to iPhone that you want to be able to use those, right? Yeah. It says there's some features peculiar to Windows that you want to use those. Because it's just like if I'm using Linux, then I won't be able to use Microsoft Word and all the rest. So I'll prefer to use Windows because I like using the Microsoft products,
So you're saying that
Okay.
but not meaning that Linux does not come with a word processing software. But
Okay,
maybe
I
I just
understand.
like Microsoft stuff.
no, I think the question was asking is why do you prefer to use a Linux?
Linux
Because
over Windows.
Windows
Over
are relatively easier to
Easier
use
to
to use.
use,
compared
yeah.
to.
It also depends on the distribution too of Linux. No, I'm just trying to say at the end of the day, right?
Which one do you use?
Uh,
Let's begin with that.
I'm
Yeah.
using Ubuntu for
Why are
this.
you using Ubuntu?
Ubuntu, yeah,
I'm using
Ubuntu is
Ubuntu
Linux.
for this,
Okay.
yeah,
Yeah.
because it's user friendly, just like
Ubuntu
Windows.
is user friendly.
Yeah.
I really scary. Ubuntu is user friendly.
So it's let's say it's more user friendly. We
Yeah,
are,
than the other
yeah, than the other
distributions.
distributions. Yeah.
No, but his question is that why are you using Ubuntu instead of using Windows? Like, because you said at the beginning that those who are doing software will have to
Yeah.
get a Linux operating system.
Yeah.
So why?
Because once that they should be able to use, let's say most servers, guys, out there. In fact, actually, the Linux operating system, majority of computers use the Linux operating systems. Are we there? Maybe not we
Okay.
who are here, right? The servers that are out there, they use the Linux operating system. And you software engineers are going to be deploying apps on servers which use what? The Linux operating system. For you to be able to maybe resolve some kind of issues that maybe can occur and stuff like that, you need to know how to use a Linux operating system. Exactly.
Question like, why do those servers use Linux, not Windows?
Because
Because
first of all,
Linux
it's
is free
lightweight.
Okay.
and
It's
open
free.
source
Yeah,
too.
exactly. Open source, right? But
It's
it's mostly
open
because of
source.
the
What do you mean?
lightweight, right? You just need once you have it, yeah, you can use just the console, and servers use just what mostly just the console, the command line interface, not the graphical user interface. Mhm. Yeah.
Open source. What does it
Open
mean?
open source means the source code is out there, it's free. You can go and see the code, right? You can customize it to what your likeness. Good morning. You can customize it to your likeness. Are we there? Unlike Windows, which is we say proprietary, right? Means you don't have it's owned by Microsoft. You don't know what those guys have put inside there. You can be stick your data or whatever. You don't know, right? So companies will not want to come and get that. We don't really know, right? But they want something which they can customize to fit them. Are we there? Hmm? All right.
Sorry, question.
Yeah, go
So
ahead.
why are those who are doing data science, why are we not using Linux?
Uh, yet you know, answer that. But I mean, you guys will have to use some Microsoft softwares, right? And using Windows will be best for you to
I
have
think
the
so.
better interaction of it. You get it, right? Yeah.
But generally, like worldwide for data science, we don't necessarily need like Linux, like the Linux operating
No,
system.
I don't think you necessarily need it, right? Yeah. Like I said, right, at the end of this, more of your likeness, right? And what you want to do too, right? Yeah. That's it. Okay, let's continue. Where was oh, I've not actually even spoke about the kernel.
And I spoke about the kernel until you did the notes.
Okay, yeah, yeah. I mean, like for interaction, but well, we'll see it. Yeah. Okay, device drivers. So that's the part of system softwares, right? While device drivers for communicating with hardware, right? Like maybe you have a device driver for this your port, for your mouse, for your keyboard, all this kind of stuff. Yeah. Utility software, antiviruses, backup tools for maintenance. Okay, all right. Like things like antiviruses, right? Well, there are many antiviruses out there, Norton, whatever. Yeah. So the
But those
four.
some of them are actually the
Yeah. Yes.
Let's not get there, please. Let's continue.
That's the
So,
silent truth. People don't really talk about it.
so firmware slash bootloaders for basic device control like BIOS, that's basic input slash output system, or UEFI, Unified Extensible Firmware Interface. So they initialize, the means is they initialize your computer's hardware and load the OS. Are we there? Right. So your computer is not on, which means you can say your OS2 is should I say is asleep or it's not on, it's not working right. So you need something which will help to load the OS so the OS can take over now. You get it? Mm? That's where we have the firmware or the bootloaders. Is that clear? Okay. Language processors so translate code from high level languages into machine code binary, including compilers, interpreters, and assemblers. Yeah, so when we write our code, so yeah, you guys will be writing code. I mean, whether software engineering or data analytics, right? I mean, you guys be using Python somehow too, like Python scripts, right? Yeah, so it's high level in the sense that you, the user, quickly understands what you're doing. Mm? Like, okay, maybe this a loop, the for loop, or let's just go down to a variable, maybe a equal to 2, right? You're saying that a should have the data 2, right? Or let me not break it down. But a should have the data 2, right? Like in maths, right? A equals to 2. That's clear. So you, the programmer, understands that a is equals to 2. But how does the computer see that? So you need something to tell it, to interpret it, are we there, into a language which the computer understands, which you know the language, right? Ones and zeros. That's clear. Okay. Some other categories include system libraries, so collections of pre-written code for common tasks, and yeah, virtual machines, monitors or hypervisors, which create and run virtual machines. You know virtual machines. Okay. Or just jot it down for research. Yeah. Okay. So I've talked about system software and all those different categories: operating system, um, device drivers, firmware, and again, these are all under the system software category. Right now, and we made so that's a type of software, right? System software, and we also have what, the application softwares. So application softwares, they are used for common day-to-day tasks. So I mean, when we talk about all software, I don't mention, I mean, our Microsoft and all the rest. So this the category in which they fall, right? Our games that we're playing, the VLC for watching movies, WhatsApp, Facebook, yeah, they fall under this category. So word processors, Microsoft Word for typing documents. IDEs, that's integrated development environments for writing code. Web browsers like Chrome, Microsoft Edge, Firefox for surfing the web. Media players for playing songs, movies, and viewing images. Games, they're all found under this category, and so on and so forth. Exactly. And you have seen that what they are all managed by the OS. The OS manages all of these. Mm, yeah. When you install it, the OS knows that okay, this is an application. So maybe when you come and tap it, it knows that I have to go and load it, I have to do this, I have to do this. Manages all of that. Mm, yeah. Tells the CPU that this is what the guy needs. So do this, do it like this. That's right. Yeah. So these are additional resources which you should visit. So see, there are videos here. There are links to you. These are YouTube links. There are links to some researches, PDFs. Also, click up links. So algorithmic thinking, computer generations, introduction to computer science, introduction to computing, introduction to the computer system itself. So there you're going to actually see like a video that demonstrates how the computer systems and everything. So yeah, you guys should visit these resources. All right, so that's it for this one. Go to the next page. Okay, so the von Neumann architecture. The von Neumann architecture. So let me give you guys maybe 5 minutes to process what we did already, guys. Then we'll enter the von Newman's architecture. So yeah, we did introduction to computers, see what a computer is, parts of the computer, seeing some basic parts there. Also now the CPU is different from the system units. See what the operating system is. Now if you take a laptop and you tell that it runs Windows. In fact, now you understand why we go and like is it iOS, is it iPhone, is it Android? Yeah. And you know there are some things that are easier to do with Android phones, some things that are easier to do with iPhones. That's why I use iPhones, so I don't know if it's actually the case. But maybe guys, I mean people like using it, so it's always has its benefits. Same to Windows, or things that are easier with Windows, some things that are easier with Linux, right? Yeah. And like we saw, why would someone choose Linux over Windows? Or someone choose Windows over Linux? Yeah. And there's still Mac OS as well. Any questions so far?
Yeah, but not about the class. Okay, like for example, we're using the iSparks, platform. Why not use Google Classroom?
Why not use Google Plus?
It's their developed
Yeah, I get it. I'm asking why. Why did you decide to
create
create? Yeah.
I mean, with us, we can customize it to our likeness, right? Based on our what we are giving out. You get it? Google Classroom is it already has a structure which if you are using Google Classroom, you have to follow their structure the way it is. Are we there? Yeah. But there are many things that we envision for this as a whole. Mm. So we love to have our own tool which we can customize such that it's going to like embrace all what we have in mind. Yeah, you get it. So I'm sure you guys will notice still under development. Like keep working. Sure you guys are having some kind of good stuff. Yeah. Yeah, it's going to be there. I mean, it's relatively new, right? And still under development. We're going to be adding, subtracting, this, like you said, give feedback. Yeah, the feedback is highly appreciated. Yeah.
This is the first session. This is
The
the first two.
no, this is the third chord. Yeah.
Wait, I
Okay,
think
chord
it's the first
one did
one.
not use ice then. Chord two used it minimally, like started around the mid part of it. Yeah. But we actually started with ClickUp. We're using ClickUp. That's even what I'm using right now. Yeah. We're using ClickUp. So chord one guy is actually using only ClickUp. Yeah.
That's another platform.
Yeah, that's another platform. Then chord two we started with ClickUp, then we migrated to IS7. Yeah. Then now you guys using IS7.
So this was the name of the tutor for data analytics.
It's Miss Megan. Yeah, it's Megan and Benny.
Are we going to see how to
Hopefully.
Also, another question by an aside. I heard that for cohort one was free.
Really?
Yeah.
Yeah.
So for data analytics, cohort one was also free.
Data analytics is the first one.
Yeah, so
Okay,
like
the
this one,
first-
why is not free?
Wait, This is the first cohort for data
For
analytics.
data analytics, yes.
I don't usually like first cohort because they are usually the specimens. Usually use them to test things, refine for further batches. Yeah,
Anyways,
yeah, they'll make the mistakes with us to learn
uh,
now to better the next cohort. Uh, yeah, that's how first timers usually suffer. Okay. Okay.
well, is it really should we really say so far, so far?
Most times they're usually the specimens. They used to experiment. So after this first cohort, we now see wait. Those now coming out in the next batch have a taste of perfection.
Okay, let's put it this way. If you want to learn a if you want to learn a new something new, right? Um, you start suffering. As within that suffer that
You
you
learn
learn
better.
better, right?
Okay.
Okay. Someone now will see you maybe 1 year after, like let's say the 1 year prior to that 1 year, I'll be suffering and suffering. But someone will come and meet you 1 year after that will be like, man, this guy is just flying and red. But not know that it's because that suffer that actually got to where you are. So what I'm trying to say is they're just going to be getting maybe um they're going to get, like you said, the refined stuff, right? After we've experienced it with you guys.
Well, not everybody must suffer. Some people need to suffer for others to enjoy.
Yeah, but you're not answer my
Exactly,
question.
that's it, right? You guys
Yeah,
are
but
suffering.
then
Yeah,
her question
yeah.
is
Let's get
valid.
back to our question.
Since we are the test experiment.
Actually,
All right, let's continue, man. So the von Neumann architecture. So let's take a glimpse at computer architecture right here. So we've seen an overview of the computer, right? Now let's see. Um, let's look at the design of the computer as a whole, right? The architecture. Okay, so computer architecture is the conceptual design and fundamental operational structure of a computer software. So before you want to implement something, you at least you think, you brainstorm on it first, right? Okay. So it answers questions like what? How does a computer execute programs? How do instructions and data move inside a computer. How do hardware components work together? I've seen that this one is for storage, this one is for computation, this one is for this, it's for that, it's for that. How do they work together? I've seen that okay, you have to feed it with data. I mean, how does it even get that data? How does it know I have to use this program? All of these things, right? Yeah. So one of the earliest and most influential models of computer architecture is the von Neumann architecture. So what is a historical background for it? So I mean, von Neumann is obviously the person's name, right? Yeah, John von Neumann in 1945 introduced in the first draft of a report. Yeah, so that's his report. One, he introduced one of the earliest digital, get it right, digital, digital computers became the foundation of almost all modern computers which we see right now. So before this model or architecture, programs were often hardwired into the computer. So changing the program meant rewiring the whole hardware, obviously. Okay, I'm wondering how it was that time. Okay. But Newman's key insight. What if instructions were stored in memory just like data? Because I mean it was being rewired and all the rest because we're not actually storing it somewhere, right? If maybe I'll quote your code outside, then take the instructions where I am, like I don't know how they did it, but it's like it's somewhere, right? Then you go and wire it now inside to the laptop itself, to the computer system
Just like
itself.
embedded systems.
Yes, exactly. You go and put it there now, then it runs it, and then if you want to change the program,
As you remove the wire,
yes,
wow.
you get something like that. Yeah. So it's that the computer could not do all of these as things that we have now, store the data, have a memory, and all of those things. They were not actually there, right? So the von Neumann's architecture now is actually revolutionized everything. Yeah. Okay. The key concept. So stored program concept. So stored program concept. We have so program instructions and data are stored in the same memory. The CPU fetches both from memory as needed. So I'm sure there's going to be a diagram under here which you can see some cool stuff. Okay. I mean, this just is the picture. We're going to see how it is. Okay. Why this matters? Programs can be modified, loaded, saved, and reused. As such, software becomes flexible. Mm. Now you can open your WhatsApp, you see your latest messages, you see messages that you send whenever, all this kind of stuff. Why this matters? We're already there. It enables modern operating systems like what? Compilers and multitasking. Yeah, so obviously enable stuff like that. Like modern stuff which we have right now are due to the fact that we can now maybe store data and instructions, right? I can imagine how your phone should have been if you had to. Let's never think about that. Right? You will not.
Maybe that's where
And
the
most of
whole
it,
concept of this disc. Remember the first DVD deck we used to use that they had this one disc to use for
yeah.
movies and movies like that.
Mhm.
Maybe it was because of all those things, since they could not have stored videos, that kind of thing. So they had to burn If you get into those things,
And
you
then
want to
carry
watch, you
it.
put,
Yeah, you go and put
you
it.
finish, you remove,
Movie,
you pick another one,
exactly.
you
So
put.
you can just see a concept there, right?
Yes, yes, yes.
Yeah, yeah. That's it. Means he just try to tell you that most of the things at that time was special purpose, special
Yeah,
purpose, special
special
purpose,
purpose.
special purpose. Yeah. Okay. Ah, example, memory may contain so also this like how the memory can be, right? So memory has different addresses. So in address 1000, it has this particular instruction. At 1001 has this other instruction. 1002 has this other instruction, just like that, just like that. So the instructions are found in memory. Like we said, what's a software? A software is just a set of instructions. You get it? Yeah. So yeah, like I said, your WhatsApp is just instructions. When you click the WhatsApp to open it, it loads the instructions for WhatsApp there. Mm? When you click a specific chat, what happens? It goes and fetches that instruction to open that chat and displays the messages for that chat. Mm? Are we there?
Yes.
When you want to type your stuff, it goes and fetches the info, the instruction to type. You type it, when you send it, it gets the information, the instruction to send and sends just like that and goes and keeps it back. It does it so fast that you actually don't know that it's doing a lot like that, right? Yeah. Okay. So it's at different instructions. There's somewhere it knows the address for each of them. It knows that okay, I'll go and get this one. This if you want to do this one, I'll go and get it. Just like that. Yeah. So both instructions and data they live together. Yeah. So it's that instructions, this particular slot has this instruction, this particular slot has this instruction, and that slot has data inside, and that slot has instructions, and that slot has data, and that slot has instructions. Are we there? Yeah. So as you're typing, obviously what you're typing has to be stored somewhere, right? But now the instruction to maybe type is something else. You get it? Yeah. Okay, core components of von Neumann architecture. So this is a high level diagram. So we have the input devices, we have memory which stores data plus instructions. Then we have a CPU which has to load that data or instructions or data and instructions from the memory, right? And when it gets it, what happens? It has to process it using either of these different chambers or different stuff, right? It has the ALU, the arithmetic logic unit, it has a control unit, it has registers as well. Then we have output devices. So it's that input, storage, processing, output. Are we seeing? That's like a brief summary of all what the computer does, right? It takes, it stores, it processes, it gives out. That's clear. Yeah. So this is like the fundamentals of a computer, obviously. Like if you say like in this our modern age, let me put it like that, right? Because it's that prior to this von Neumann architecture, the computer was something else, right? Then after the von Neumann architecture, it's that it started defining a computer in a different way, right? So in this our modern age, you can say, okay, if you're thinking of, okay, this is a computer, then you should be thinking of things like this, right? That it has a way of getting the input, it has a way of storing it, it has a way of processing it, it has a way of giving it out. Is that clear? Okay. Okay, central processing unit. So this obviously the core, right? The brain of that his architecture. The guy who and those things. Okay, so the CPU is the brain of the computer. Okay, that. What are the main responsibilities of the CPU? It fetches instructions from memory. So I've already seen how what the memory is, right? And we know that it stores instructions and data, right? So the CPU has to fetch those instructions from the like instructions for the processes that it has to do, right? For the computation and all the rest. I mean, the CPU is dumb, right? It needs something to help it. So it needs to get those instructions and use them. Get it? Yeah. Then when it fetches them, what happens? It has to decode them. It has to decode them to actually know what they mean, right? Because oh, well, it has to decode them because
The decoding is part of processing.
yeah, it's part of the processing, like what the computer has to do, right? Yeah, what the CPU, so what the CPU has to do. So I fetch it. So okay, what does this data say? Try to analyze and whatever it does, right, to decode it. Mm? Yeah, like interpreting that data. After interpreting, then he has to execute the instructions that the data or that is the instructions. Yeah, he has to execute the instructions based on what they say, right? Then after that, it should store the results. Exactly. So fetch, it fetches from the memory, it decodes inside. So when it fetches it, which means right now the instructions are inside here, right? Decodes it, meaning it uses either these guys, right? Executes it, obviously uses one of them too, and then stores. So it has registers. So registers are there for storage. Are we there? Yeah, so you can store some things inside the registers. Or you just cache memory and the rest. But let's not go that far. Then yeah, that's it. So the CPU has two main parts. Now let's see the ALU and the control unit. So arithmetic logic unit. So the ALU performs arithmetic operations plus addition, subtraction, multiplication, division. Exactly. So you said there's one part of a computer of the CPU that someone just do these arithmetic operations, then logical operations as well, and or not X or. I think you guys saw it in the foundation courses. Yeah. Then comparisons to agree, is this greater than, is this less than, is this equal to. Uh, yeah.
Some of these things are still under that.
Yes. So you said the von Neumann guy really sat down and designed all of this, thought it out, everything. I mean, that's cool, right? Yeah. But looking at it here, it's like it's so straightforward. But based on the time where they were, to actually come out with something like this, it's a whole lot. Yeah. But you can see how simple computers were at that time. Then you, I don't know, it's like just reason out of the box, right? Everything has changed. So cool. So examples of what the ALU does: five is five plus three, five A and B, X, like checks if X is greater than Y. So the ALU does not store data; it only processes it. Are we there? Yeah. Hmm? So we get the fetch, the CPU fetches it, decodes it, then the ALU now based on what the, if it's, let's say it involves, let's say one of this stuff, in fact, it mostly involves one of this stuff, right? Adding things, logical operations or comparison. The ALU does the stuff. Are we there? Then now let's see the control unit. A control unit. So it directs all operations inside the CPU. decide what happens next, sends control signals to the memory, to the ALU, to the registers. So registers are a tiny superfast storage location inside the CPU for data actively being used. Mm. Data that is going to be used frequently, right? The CPU must not necessarily go and store it right at the memory. Can store it closer to it, so it'll be easier for it to fetch and use. Are we there? Yeah.
So what you're saying is that the ALU, that's the arithmetic logical unit, is in charge of all the computation, that's processing, like the CPU, right? Why the control unit just directs,
Exactly.
tells you what to do next.
Yes, yes. Like maybe okay. Like since it fetches and decodes, like okay, we have decoded it. It shows that okay, we have to do addition. Oh, hello, that's your work. Do it. Maybe we have to do comparison. Oh, hello, that's your work. Do it. Oh, right now we have to store registers. You get it? It's like yeah, exactly. What next? What? Yeah, that's it. Input also sends control signals to input output devices, right? I mean, it fetches means sometimes you enter, right? It stores, and after storing, it has to give it out, obviously. It has to go out, right? Yeah. Okay. So think of it as a conductor of an orchestra. Yeah, that's a good way of putting it. And when I was reading it, I was flipping my hands. So that's it. Yeah. So registers. Oh, welcome, Levison. So this is a quarter training.
Two.
Yeah, quarter software engineering. Yeah. So okay, let's continue. Registers. So you can always meet him in case you have any doubts. It's
For
just
software
software,
of what?
software guys. Yeah.
Assumption.
Come.
No, you said for software.
Yeah. Say especially software guys. Does not mean data guys shouldn't. I mean he might help somehow, right? Yeah, one or two. Okay. Registers are very small, extremely fast, and are located inside the CPU. So common registers we have the program counter, so it holds address of next instruction. So say we have different registers, right? Register is not just one thing that does everything, but like they're all a register like is divided into different stuff, right? This one has it does this one does this one does this one does this. So we have the program counter which does what? It holds the address of the next instruction. Hmm? The address of the next instruction. Instruction register, it holds the current instruction. We have the accumulator which stores intermediate results. Like this, you have A plus B plus C plus D. We do this one, you have to store somewhere while doing the other one stores and they compute all of them, right? So those are like intermediate. What's one? Service. So intermediate stuff. Okay. Then we have MAR, that's the memory address register, and MDR, memory data register. So these are different registers and they all have their own purpose in the CPU, right? Based on what the CPU wants to store, you know, that okay, well, the control unit is the one directing it, right? This one you go to the one, this one you go there, stuff like that. Yeah. Note, registers are much faster than RAM. The key difference between registers and RAM is that registers are small and super fast storage inside the CPU, holding data currently being used. Because the CPU only fetch if it has to use it at that time, right? So when it fetches it, you have to keep it somewhere, right? While it's using it to registers now come to place. Wasn't to fetch it when you could just leave it in the memory and be using it small small. When you fetch it, put it now in a super fast environment, right? The one which is like closest to you while you're using it. You get it? It's just like, let's say, um okay, you came here with your laptop, your back and everything. Why did you not, well, another option could be, okay, you come with maybe just your book. Then when you need a laptop, you go and get it and go. It's that's long, right? Just come with everything. And I mean, table is there, you keep it. Right? When you need this, you just extend your hand and use. Just like that. So that's the same reasoning. Are we there? Yeah. One other person will be like, I mean, it's just a computer. I mean, just get that thing there. But
So the RAM is the whole house, actually, while the register is the state.
yeah, we can put it like that. Yes. So the RAM is like your house, right? In your house where your things are normally kept, your data, all your things are kept. Then this like the registers here now. Like maybe the CPU, this where you have to do the thing, your work, right? So you get all your tools from the house and come and keep it now in your register, which is the table. And when you need to just extend and click, yeah, and use. Hmm? Yeah.
And the RAM is still the boost to all.
Yes, yes, yes. Like if I'm doing this instruction, I I take the next one right from the RAM, just like that. Yeah. Okay. RAM is larger and slower, sitting outside the CPU, holding data for running programs. You get it? So it's like I said, when you touch your WhatsApp icon, what happens? It loads all the instructions for WhatsApp on the memory. But it doesn't mean you're doing all the instructions for WhatsApp